Hello, welcome once again to Mathematics Meal. Today on Mathematics Meal, we are going to look at the concept of logarithm. Subscribe to our YouTube channel and make sure that you follow us on Facebook at Mathematics and Science Meal. Thank you. Now we know that we have different aspects of what? Logarithm. Today the logarithm we are going to consider is logarithm without tables. Maybe you are conversant with the logarithm with tables, where we find logarithm of numbers greater than 1 and logarithm of numbers less than 1, where you find the characteristics and the word and the mantissa. But today, the aspect of logarithm we want to consider is the one that you don't need table, you don't even need calculator to handle such logarithm. Join me on this beautiful journey. Let's begin. All right, we'll start by defining logarithm, and also we'll look at other basic things that we need to consider in the concept of logarithm. That's what we're going to consider in this part. So it is important that you pay attention and stay away from every form of distraction. Let's start the journey. Okay, so what do we mean by logarithm of a number? So we say that logarithm of a given number is the power or exponent to which the base must be raised in order to form the given number. So the power or exponents to which the base must be raised in order to form the given number. The given number is the logarithm of what? Of the given number. The number that will become the power of the base in order to form the given number. That's what we mean by the logarithm of a number. So let's break it down using symbols. Thus, the logarithm, if the logarithm of a number, say A, in base B is x, then it implies that b raised to power x is equal to a. Thus, if the logarithm of a number a, let's say the number is a, and the base of that logarithm is b, if the logarithm of a in base b is x, it means that b raised to power x is what? Is equal to what? A. We'll go further to explain this. Yeah, we'll go further to explain it. We know that in mathematics, grammar is not the issue. We just need to break everything down to mathematical expressions so that you can understand it more. So let's go further. The short form of logarithm. The short form of logarithm. Short form of logarithm is log. So that's what we'll be using. That's the short form that we'll be using. So anytime you see log, not the log of wood anyway, but this is the log for the short form of what? Logarithm. So we'll be seeing this from time to time as we study the concept of logarithm. So the short form of logarithm is what? Is log. So now let's go back to this expression. We'll return to it just in a short while now. So generally, logarithm of a number will be written using this log. So generally, logarithm of a in base b will be written as log a in base b. So when we represent a logarithm, this is the number and this is the base. So logarithm of the number a in base what? B. So log a in base what? In base b. So logarithm of a in base what? In base b. So this is general way of representing logarithm. So one can say logarithm of 27 in base 3. This is the number, this is the base. So the base is written as a subscript anyway. So this is the base, this is the what? The number. So that's the general form of representing what? Logarithm of numbers. The general form of representing logarithm of numbers. So from here now, let's see if we can get back to this now, so that we'll now make more meaning to this definition of what? Of logarithm. So therefore, if the logarithm of a in base b is equal to x, then if the logarithm of a, the number a in base b, is equal to what? X, then what it means is that log a in base b is equal to what? X. That's what it means. Thus, a will be equal to b raised to power s. So what do we mean by logarithm now? The logarithm of a in base b is this x that will become the power of b for us to find what? For us to form what? A. So logarithm of a in base b is the number s such that if this number is used as a power on the base, we are going to find what? A. Using numbers, we make it clearer now. So let's see examples. Examples. I can say that log 100 in base 10 is 2. Why? Because 10 raised to power 2 is what? 100. So log 100 in base 10 is 2. Why is it 2? Why is it not 4? Why is it not 10? Why is it not 6? Why is it not 1? Because when 2 becomes the power of 10, we form 100. So log 100 in base 10 is 2, because if 2 becomes the power of what? 10, we are going to form what? 100. You cannot say that log 100 in base 10 is 1, because if 1 becomes the power of 10, we are not going to get 100, because 10 raised to power 1 is 10. We cannot say that log 100 in base 10 is 3, because if 3 becomes the power of 10, we cannot form 100. So logarithm of a number is what will become the power of the base to form the number. So if we go further, we can also say that log 125 in base 5 will give us what? Will give us 5. Sorry, will give us 3. Sorry. Because when 3 becomes the power of 5, we form 125. 5 raised to power 3 will give us 125. So because 5 raised to power 3 is 125. 5 raised to power 3 is 125. Remember, 5 raised to power 3, if you know your indices, will be 5 times 5 times 5. And 5 times 5 is 25. 25 times 5 will give us what? Will give us 125. So why we stated here, why we have to state that the logarithm of 125 in base 5 is 3, is because when 3 becomes the power of what? Of 5, we form 125. Logarithm of 125 in base 5 cannot be 2. It cannot be 2, because if 2 becomes the power of 5, we cannot have 125. So logarithm of a number is what will become the power of the base to form the given number. So one more example. We can say that log, let's say log 32 in base 2. What's the answer? Log 32 in base 2 is what? 5. And someone will ask, why is it 5? Why is log 32 in base 2 5? Because when 5 becomes the power of 2, we form what? 32. So because 2 raised to power 5 will give us what? 32. So I believe with these examples, the meaning of logarithm is clear. So whatsoever thing that will become the exponent of the base, so that we can form the number, that's the logarithm of the number. So logarithm of 100 in base 10 is 2, because when 2 becomes the power of 10, we form 100. Logarithm of 125 in base 5 is 3, because when 3 becomes the power of 5 here, we form 125. Logarithm of 32 in base 2 is 5, because when 5 becomes the power of 2, we are going to form what? 32. I think that is very clear. Very, very clear. So when we are trying to find logarithm of a number, we are trying to find the value that will become the power of the base in order to form the number. All right. So far, so good. I believe that what we have treated so far in this introductory part of logarithm is very clear to all of us. So let's say a few more things then before we'll end the class today. Now, you cannot find the logarithm of a negative number. I know some of you will be wondering, what do I mean by that? You can pick your calculator and try finding log minus 2. Log minus 2. You see it's going to give you error. So you cannot find the logarithm of a negative number. So the logarithm of a negative number will not do what? Exist. So a negative number, it cannot be a sort of a domain, right, in logarithm of numbers when you do functions. So you cannot find the logarithm of a negative number. So you can note it. You can note it. So the first thing we need to note, the logarithm of a negative number does not exist. The logarithm of a negative number does not exist. That's one. The logarithm of a number can be negative. So you can find logarithm of a positive number and the answer will be negative, or you cannot find the logarithm of a negative number. So you cannot have log minus 3. It will not exist. But it's possible that you can find log of a number, let's say any number, you can find log n and the answer will be negative. But if you want to find logarithm of a negative number, it will not exist. But you can solve logarithm and at the end of the day, the answer will be negative. But if someone asks you to find log of a negative number, it does not do what? Exist. So, the second thing we need to note is this. To solve problems in logarithm, we need the laws of logarithm. So to solve problem in logarithm, we need the laws of logarithm. And that's what we are going to consider in our next class, the laws of what? Logarithm. So anytime you want to solve problem in logarithm, you need the laws of logarithm. Remember the things we have considered so far. We have defined logarithm and we gave examples. And we also emphasize on the need for students to know what the number is and what the base is. This is the number, that's the base, number base, number base. The base is usually written as what? As a subscript. The base is usually written as a subscript. So we must know how to identify the number and the base. And we also emphasize that the logarithm of a number is the exponent of the base to give us the what? The number. So what will become the exponent or the power of the base in order to form the number? That's what we mean by logarithm. All right, we're going to end the class here today. But remember, there is need for you to watch other videos on our platform. Go to our YouTube channel, Mathematics Neo 1. Look for videos in other topics and make sure you watch them so that you'll be well grounded in mathematics. Remember, logarithm is very wide, so make sure you follow this series on logarithm and watch every video on logarithm so that you will be able to defeat all principalities and powers that are in logarithm. Thank you and God bless you. I still remain your friend, your tutor, and your brother, Engineer Ike Okechukwu. I love you.